Hey guys, welcome to this video lecture series on the subject of polymer science and technology. I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. In previous video, we have discussed what do we mean by the ionic polymerization, and we have seen three steps of ionic polymerization as initiation step, which was followed by the propagation step, and lastly we were having termination step. Well, if you have missed that video, you can find it in the I button over here. Now, having said that, in this video we are going to cover the coordination polymerization. Well, we have said that in very first video that step polymerization has three parts, or it has three categories. The first one is the free radical polymerization, in which we are used to produce free radicals. While the second case is the ionic polymerization, in which we carry out the polymerization process with the help of ions, either in the positive ions or in the form of negative ions. But now in this video, we are going to discuss the third category of the step polymerization, and that is coordination polymerization. Well, this coordination polymerization is nothing but the special technique in which we use novel class of transitional metal catalyst which are used for the polymerization process. So basically this transition metal catalyst are the complex molecule or complex combination of monomer and catalyst. You can see here on the screen that this monomer catalyst complex between organic metallic compound and the monomer is formed in the first step. So this novel catalyst is nothing but it carries two components. One is the metallic and another one is the our monomer. So when both the thing mix or both the thing combine together, it form one special kind of a catalyst, and this catalyst used for the polymerization process. And this process is named as the coordination polymerization. So here in this image you can see that this type of the catalyst, you can see that this organic metallic catalyst, here you can see that it has CH2 which is attached with this R, that is nothing but the chain of the carbohydrates, and this chain is attached with some metal that is represented by the Mt. So we can say that this particular component is our organic metallic compound. Now this organic metallic compound when merged with one monomer, or we can say that when it joined with monomer, it produces the catalyst that we are going to use throughout this process of the coordination polymerization. You can see that this compound is now reacting with our monomer, that is nothing but one butyl or isobutyl. You can see here we have used the isobutyl as the monomer. So when this reaction between these two things will happen, it will produce the novel catalyst that we are discussing throughout in this lecture, that is used for the coordination polymerization. And that catalyst compound is look like this. You can see here. So this is again the R which is attached with this CH2 and our metal represented here as the Mt. So now where is our monomer? You can see here this is the monomer, that is CH2 which is attached with CH. Then again double bond with this CH, and this CH is attached with this CH2. So this complete ring structure can be referred as the monomer catalyst complex that is used for this polymerization process. And this will act as the active center for this polymerization chain or the growth of polymer. Now let's just understand what are the different steps that are taking place in this coordination polymerization. You can see here on the screen that special type of the metals that are nothing but your titanium, rhodium and nickel are used to manufacture such type of catalyst. So here in this image, in place of this Mt, we are going to use titanium, rhodium and nickel. Sometimes we are also using aluminum as a metal. So now these are the different type of the metal that are used to manufacture such type of catalyst. Now the formation of this monomer catalyst complex that we have already discussed is in the form of coordination bond. So this bond is referred as the coordination bond. You can see here in this image in which carbon atom and the metal are joined together. You can see here that this coordination bond is made between carbon atom of the monomer and metal. So we were having this carbon atom inside the monomer is now attached with this metal here M. So this particular bond is referred as the coordination bond, or it is generally sigma type of the bond which is not easily breakable. So therefore this polymerization process is referred as the coordination polymerization, because the bond which are used to connect this metal and carbon is the coordination bond. And ultimately this metal and carbon bond will act as the active center for the growth of polymerization. So this was all about the basic introduction to the coordination polymerization. It is mainly based on the catalyst that we are using for this polymerization purpose. Now let's see how this polymerization growth based on this catalyst. You can see here this metal carbon bond that we are discussing is formed in the monomer catalyst complex, which is actually acting as the active center from where the propagation of this polymer will take place. So we have discussed that any polymerization process involves three steps. The first one is the initiation step, then it is followed by the propagation step, and lastly we will have termination step. So in the manufacturing of this catalyst, this special type of catalyst is known as the initiation step, in which this metal catalyst comes in a contact with the monomer and produces one complex catalyst of metallic and monomer. Now after initiation step, this propagation step comes in a picture, in which this carbon and metal bond act as the active center onto which this propagation will carry on, and further addition of monomer will take place, and we will have long chain of the polymer. Now this step can be seen in this particular image. You can see that this is the same compound that we have formed in the initiation step. It has R, CH2 and metal. This is particularly this thing. Let me just take a pen so that I can explain you this thing in a better way. This particular thing is our organic metallic compound, or we can say organic metallic catalyst, and it was combining with our monomer. This thing, this is our monomer, is being combined with it, and it is producing complex catalyst of metal and the monomer. Now this entire structure will act as the catalyst for this our entire process. So whenever new monomer will come in a contact with this catalyst, it will form long chain. You can see here, this is the new monomer of isobutyl is coming in a contact with this particular catalyst. So now the structure will rapidly change its form. You can see here this isobutyl is connected with this R, and at the last carbon, this ring structure is shifted. So we have also seen this thing in all of the polymerization process. In the free radical was used to transfer to the last carbon, right? So the free electron from the initiator was shifted to the last carbon or to the last atom of the polymerization chain. And we have also seen in the ionic polymerization, ion were used to transfer from intermediate carbon to the last carbon of the polymer chain. So similar thing is happening here in the coordination polymerization. But instead of any electron or any ion, here we are shifting entire ring structure that we have produced in the initiation step to the last carbon of the long chain. You can see here that this structure, this particular ring structure was in the intermediate carbon. But now because of the propagation step, this ring structure is shifted from here to the last carbon atom, to the here. You can see here. So if further addition of new monomer will take place like this is the new monomer is attacking on this ring structure. So it will added up together, and again this ring structure will shifted to the last carbon. Like this, you can see that this R chain was here, and now this new monomer here, you can see that. Let me just take a pen one more time. This R thing was we were already having right from the previous step, and now this new monomer is added together, and we can see that this ring structure was initially here, but now after this propagation step this ring structure is shifted to the last carbon of the long chain. So this is what do we mean by propagation step in the coordination polymerization. But This coordination polymerization is more about the catalyst that we are using for the initiation step. The rest of the thing is very much similar to the free radical and ionic polymerization. So this was all about coordination polymerization process, and this conclude all the step polymerization. We have seen the free radical polymerization, then we have also seen ionic polymerization process, and lastly we have seen coordination polymerization. Well, this coordination polymerization is again important for the exam point of view. It is basically nothing but all about the catalyst. This catalyst that we are using in this coordination polymerization is the heart of this polymerization, which is the complex mixture of one organic metal and monomer. So both the thing will combine together to form one special catalyst that we are going to use in this coordination polymerization. And actually this catalyst act as the initiator as well, and it initiate the polymerization process and shift its active center to the last compound or last carbon, so that we can have long chain of the polymer. Now, in the next video, we are going to discuss one special type of coordination catalyst that is known as the Ziegler-Natta catalyst. This Ziegler-Natta catalyst is very important and it is used in so many industries, and it has several different types. But what but the basic idea and the basic concept of Ziegler-Natta catalyst is based on this coordination catalyst. Well, we will see this Ziegler-Natta catalyst in very deep in the next video. Till then, keep watching, keep learning. Thank you.